Thank you, thank you, thank you. Do we have? Oh, cool, cool, cool. So, hello, my name is Pavlo Golub. They call me senior developer. I still feel like I'm young and pretty young developer, so yeah. So the Cybertec, the company that I'm working at, we are Postgres specific. So whatever stack you have, we can handle it. But the main thing stays. You need to run Postgres. If you cannot run Postgres, we can run it for you, and you can become our client. So we have several branches. One of them is in Warsaw. We are hiring. If you want to work with me, apply, and we will see. So agenda today. Today's agenda. This is like the full-length 45 minutes talk. That means I will need to run through all of these slides because we have only 25 minutes, and probably my live demo will be a little bit condensed, but I will gladly meet you after the talk at the QA section, and I will show you what I have in details, and we can spend more time. So, okay, the silly question, why we want to monitor databases, well, mostly because of money, right? Because we have a lot of cloud providers, so we need to know how much money we spend on them. So if we will trying to tackle the monitoring question, we can divide it into several levels. First one is the high level, then we want to monitor system we are running on operating system or Kubernetes or Docker or whatever, and then comes the Postgres specific. Okay, so high level is simple. We just want to ping the database. For example, if you are an application developer, you are interested in the database is active and it can handle your queries, and that's it, right? The next thing is the sysadmin, so they want to know the CPU, the memory, all the things. But again, different operating systems, different environments. Does the same metric mean the same on the Kubernetes and on the live hardware or not? If we look on the Postgres specific monitoring, we can divide it into 3 layers, so-called 3 pillars. First one is the log analysis, then statistics collector, and then extensions. The Postgres itself is very mature and old software, and it relies heavily on logs. Whatever problem you have, you always should look into the logs first. We have a special function, die gracefully. So before the postmaster, the main process dies, it will write a message to you, oh, I don't feel good, but that's why. Of course, we have several known and standard de facto tools. If you want to try, I would recommend the pgwatch. It provides you with a lot of details from your logs. If you want to use some kind of ad hoc tool in your terminal to know what's going on, pgwatch is a good choice. Don't forget that the login configuration is very important. As the last major 18 version of Postgres, we have 44 different configuration parameters. Probably you want to tune some of them. First of all, how you store the log. Do you want CSV or do you want JSON? What do you want to log? Intervals and so on, timeout and so on. Statistics collector is the internal Postgres machinery that is constantly measuring internal metrics inside the system, inside the Postgres, store them, and then provide you with these metrics via the system views. That means you cannot change. It's not a table, but you can query them, right? So if you want to tune the parameters that affect the statistics collector, all the configuration parameters start with the track prefix. Then we divide into dynamic and cumulative views. Dynamic is what we have right now, right? Like a temperature. So what is going on right now? What statements are running now? How many CPU is now? How many memory now? Then cumulative views is a counter. It always increases. So if you query it now and then you query it a week later, the number will be greater and will show you the difference during the process. That's why when you try to investigate something on your Postgres system, first you need to reset your statistics, then you need to run your workloads for days, weeks, depends, and then on a fresh statistics you can see how your workload affects your system. The Postgres universe is famous for extensions. Some of them are shipped with the Postgres packages or installations, some of them not. The famous pgstat statements shipped with the Postgres, I recommend you to enable it always. It doesn't have like any drawbacks or any other things. And it provides you with a cumulative view on your activities. So every statement in the Postgres has, every query, every statement in the Postgres has unique query ID. So having pgstat statements enabled, we collect the information about these queries running, and we can see how long, what resources, etc. pgstat monitor, which is the extensions based on the pgstat statement made by the Percona, is kind of pgstat statements on steroids. Another one, pgstat tuple, allows you to see how bloated your table are. Buffer cache allows you to see inside your memory what we are dealing with. Auto-explain will allow you to see explain plans in the logs. Qualstat can show you where predicates, are they bad, are they good, do they use indexes, and so on. Stat-kcache allows you to measure the system, operating system metrics like CPU, memory, disk, because Postgres cannot do this. It's like operating system agnostic software. And the latest one, pgstat-plans, that was released this year probably, it allows you to see for every query, it allows you to see different plans, and you can understand why at some period of time your query performed bad. In real life, we have hard times. Everybody do it different way. Usually, everyone stores the logs for later analysis, then somehow do snapshots of the pgstat views and trying to re-implement the alerting and whatnot. If you want to see all available monitoring solutions and monitoring related tool, we have a special wiki. But please remember that the information might be outdated for some of them. Some tools probably are not alive anymore, or it's a wiki. Okay, so real-time troubleshooting versus long troubleshooting. If I want to see what's going on my system right now, right? So I have a call from a customer. Oh, we are on fire. What can I use? We have a bunch of open source real-time tools. I prefer PG Activity. That's how it looks. Bad one. Let me show you. That's how it looks in the real life. So you have a header with some system information. Then you have a grid or list with the current active statements or queries. And for each statement, you probably can see the CPU, the write, and the read, and memory it uses, and so on and so on. It's really good for ad hoc investigating. If you need to know what is going on right now, what queries are blocked or locked, and then, so I really recommend you. Another one is a pgadmin, is the standard de facto GUI many people use to access Postgres. It has very basic dashboards, like 5 of them, but since it's an open source, you can improve those and add your own. The same for dbeaver, a very popular GUI for cross-database administration. The same story. We have 3 only dashboards, so it's up to you to add more. Of course, we have a lot of commercial engine-based frameworks. If you want to try, I would recommend to try pganalyze. This is one of the youngest frameworks made by my friend. So yeah. Generic open source is also available, but they are all based on outdated and very quirky shell script that's kind to cover everything at once. So if you want something cool, I would recommend you to use Postgres-specific monitoring tools. So among those are pghero, Pova. Pova is a French team is working on them, and they are authors of these cool extensions like qualstats, kcache, and range sampling. pgclue, pgstatwiz, and pgwatch, which we see later. So pgwatch, right? Joke about why do we need another monitoring tool, right? The main principle is we have pgwatch for a reason. So usually, as a consultants, we have no time in installation or configuring something really good on the client side. We need to have a software, a tool that can be like started, collect information, and provide us with the insights in a day or 2, right? That's why we have this 1-minute setup, maybe Docker-based. We can change the dashboards. It should be non-invasive because you cannot, for example, install anything on the cloud provider, or you're not allowed to install anything in the bank, right? So it shouldn't work with the regular user permissions, read-only, no super user or something like that. You must be able to adapt your metrics to the concrete situations. Maybe you want to add some more. Maybe you want to add some business metrics inside of it to know what's going on. If we speak about architecture, that's quite simple. So we have a metric gathering written in Go. That means we have only one binary. And inside of this binary better included, we have everything, metrics, dashboards, everything. You can configure it through different ways, Postgres, YAML, environment variables. And the fun part is the measurements things, where we send our measurements. So at the moment we support Postgres, optionally with the timescale or Citus, that allows us to shrink the size of the database. Of course, we send to the Prometheus. We can write to the local files. Maybe you want to send your local file to the AI, right? So, and you as a developer can write the RPC custom thing. That means you will, in real time, receive the metrics, measurements from the pgwatch, and you decide what you want to do. Alert, store, discard, send to another place, whatever. This is like the simple architecture diagram. So on the left, we have monitored source. We call it source because not all of them are Postgres databases. So we support pgbouncer, we support pgpool, we support Patroni, high availability software. Later, we plan to support even more. So basically, everything that can talk Postgres dialect, DuckDB, CockroachDB, in theory, can be monitored with a pgwatch. And you need only one instance of pgwatch for all of these things. If, for example, you have several data centers with different databases and you want to monitor them at the same time with different instances of pgwatch, that's okay, but you can store the metrics, the measurements, at one endpoint. And if you choose Prometheus or Postgres, you, on top of that, receive predefined 20 plus, probably, dashboards. You are free to tweak them, update them, set thresholds, whatnot. Plus, you have a web UI to control the pgwatch behavior, to add more sources, to remove metrics, to change intervals, to stop something, to start something. At the same time, we support REST API, so if you have automation or your automation is a developer, you can write some things, some tools that control the whole behavior. Features. So as I told you, the statistics collector prefixed with the pgstat prefix, we cover them all. We have pre-configured dashboards for almost everything. If not, please let me know, I will add it. We support Postgres 11, which is the 2 years out of the date, so the latest supported version is 13. This is for our clients. They always like, no time to upgrade. Yeah, of course, okay. So we support like 2 major versions behind. The cool feature is auto-discovery, for example. So you have a very dynamic environment where databases are created and dropped all the time. You don't have time, or you don't need to, right, to add under monitoring the new databases and remove old. So if you set the auto-discovery mode, the pgwatch will monitor the new and the drop databases and will automatically apply the metrics to it. Of course, we can monitor cloud instances, pg bouncer, pg pool, patroni, low resources, yeah. And the cool thing is that since the metrics are plain SQL, plain queries, you can have a special metrics for business layer. So instead of using Power BI or whatever we use nowadays, you can have a set of your own metrics for your manager, for example, or for your accountant or for your CEO. Yeah, alerting is a separate topic. Alerting is not part of monitoring. It's a complete separate topic, but I want to mention that if you want on top of it to implement it, the easiest way is to use the Grafana. Then if you use Prometheus, it's even better. In Prometheus, you have Alert Manager, or you can write your own with pgdump table or pgcron, or maybe cron, so you just compare the values and you use them. So I said that you can use timescaledb and Citus to store your measurements. That allows you to use the compression built in. So, for example, if we take the real data stored for half a year for 6 databases for 3 months, it will cost you 70 gigabytes. If you use timescaledb without tuning anything, just installed extension, it will be 8 gigabytes. But don't worry, the default retention period is 2 weeks. You probably will never hit the gigabytes showing here. It's only for nice numbers. And we are working right now on even more enhanced storage layer that will allow you to shrink everything in less than 1 gigabyte. As I told you, you can use storages or sinks in parallel. So at the same time, you can send the data to the Prometheus, to the Postgres, and write it to the JSON file, for example, for a longer retention. You can send your JSON to S3 bucket. You can send metrics to Prometheus for alerting or for some specific dashboards, and you can send to the Postgres for the main dashboarding. As I told you, so our aim is to have 1 minute setup. That's why we provide you with the prepared Docker images. The production ready is only 44 megabytes. That means the binary is 35. I bet you cannot find any other software nowadays with such size. But if you want something more complicated, for example, if you come to your client and they, okay, show me your thing, right? So you can start the pgwatch demo, And inside of this container, you have immediately Grafana available, you have Prometheus available, you have Postgres available. So you are taking only connection string from your client, and immediately you can start showing on the live data what's going on in the environment. So yeah, so that's how you run the pgwatch demo. So in a 5 seconds, you have a local host 8080, the web UI. You go to the web UI, you add something as an example for monitoring. You wait 5 minutes, maybe more, to have at least a couple of measurements, and you can show how it works. Okay, so instead, if you want just to try to see how it works, how to use things, you can go to demo.pgwatch.com, and let's try this. So this is how it looks. So first of all, this is demo.pgwatch.com. First of all, we have 2 sets of dashboards predefined. First one is Postgres-based, second one is Prometheus-based. Depends what you like, you may use one or another. Some of the predefined, can you see or should I make it bigger? Okay, so some of the dashboards has an index in the name. That means we want to warn you, these dashboards are very important and they mean something, right? So for example, zero health check means that this one is good to place in the wide big screen in your office, and while you're sipping a coffee and your boss is coming and is like, all green, dude. Right? The best job ever, right? So of course, to be all green, you need to set your own thresholds. For example, for someone, 10 blocked session is okay. For someone, 1 blocked session is a nightmare. The same for longest queries and so on. Next, if we go level by level, the next one is the global database overview. It should be called instance overview or cluster overview. On this dashboard, you can see what's going on the instance level for all databases, right? So we have connections, queries per second, transactions, averages, total sessions. So you can tell how your workloads on all of your databases affect your operating system first, right? So if we sum up everything for every database, we can see how we affect the instance. Of course, later, okay, you found the database that the slowest, the toughest, whatever, and you want to see what's going on inside that database. So the next thing is database overview. Here we have details about the role of the database. Is it primary? Is it replica? How the uptime, the transactions, query runtime, how it grows. For example, database size change over 1 hour. So if you can see the spike in the database grows, something's wrong going on, right? So shared buffers, heat ratio, that shows us how much of the hot data that query needs we found in the RAM, in the memory. That means we don't need to read disk, so you want this to be 100% for all the time. Unless you are running some analytical queries, of course, then you need to read all the tables. Wall rate plus database size change. You can see how the size and how wall size are changing all over the time. The funny thing is, for example, CPU load plus average query runtime. So if you see that CPU is higher than usual and you want to exclude, or okay, you want to confirm that the database fault, you can check these dashboards. And if you see correlation between the average query runtime and the CPU load, probably one of the queries gone mad, right? And you can do your DBA magic or developer magic and change it. So the second part of this dashboard allows you to see the graphs with the login interval. For example, I said log interval 7 days, and for example, here of active sessions, we can compare how our active sessions are different from the week before, right? So for example, if you had a Black Friday, I don't know, and you want to know how to compare this like peak time with our usual workloads, you can set this log and see what's different. When you're done with the database overview, the next stop is we want to tune our queries, right? So if database is slow, then probably the query is slow. This query performance analysis provides you with the top N queries. As I told you, every query has a query ID. It should be statement ID, but I mean, I understand the idea. So usually what you want to see is that total runtime guy. So the longest guy is probably the worst one. We have a lot of things here. You can see that we measure everything, memory, disk, I/O. So you can see how much of the total database workload this query is, who ran the query, what the query was. And the fun part is, so if you choose one, you can click on it, and you immediately go to the query detail dashboard, on which you can see how query behavior changed over the time, right? So nothing interesting here, but I mean, you got the idea, right? Below the table, you have visualizations, so you can see and compare how different queries overlaps over the time. The next thing you want to know is probably the biggest and the hardest tables, right? So if we have Wi-Fi problem, I like that. So we want to see the heaviest tables in our database, usually, right? So if we go here, first of all, we as well have top N, top 5 in this case. So you can tell that stat statements table is like 2.5 gigs, but the data size is 204. What data size means is that the real data in the table minus indexes. So sometimes, some people produce a lot of indexes, like tens of them, and they consume all the space. So just dropping an index will make you rich. If you go further, you have a visualization in a tree map, so you can hover the table and you can see so in this part we have public schema and subpartition schema, and you can see this one is the biggest because it's red, this one is less, and so on. And of course, if you press on the table name, you are going to the details for that particular tables. One of the important things to know is, of course, how the size changes, how many table scans. If you have a lot of table scans, that means you probably need some indexes. Data modifications show you how heavy writable your table is. So if the writing updates are the heaviest operation in the databases. Again, shared buffer hit rates means higher the better, and less vacuum and less analyze. Okay, so we have 2 minutes.
No minutes, but you can finish.
Okay. Okay, so. Yes, as I told you, I'm waiting you at the QA session, so thank you very much.